Okay, let's talk about the curl a little bit, and at least some of the relationship between the curl and potential functions and so forth. Okay, the curl, as you should know from Chapter 1, because of course this was covered in Chapter 1, is del cross F. Curl of F is del cross F. So if F is AI plus BJ plus CK, where A, B, and C are implicitly functions of X, Y, and Z, then del cross F is equal to this determinant. And that's equal to I times this. Well, I'm not going to read it to you. You can evaluate this determinant. C sub y means the derivative of C with respect to y. So I times partial respect to y operating on C gives you I times C y, the partial derivative of C with respect to y, etc. So that's the interpretation of those quantities. Now, let's just take an example. Let's say F is Xi, which we've already proved to be a conservative field. Okay? If F equals Xi, then del cross F is the zero vector. Why? Because the A function is just plain X. The B and C functions are zero. There's no Y or Z function. So the only function that's non-zero is the A function. The A function is equal to X. The only place the A derivatives occur are here, and it's the Z derivative here, the Y derivative here. Well, the Z derivative and the Y derivative of A being equal to X, are both clearly zero. So the del cross F is zero. Now, F equals Yi. We have shown, let me put this here. Here's a conservative function. Here's a non-conservative function. Okay. F equals Yi. What do we get? Well, now the A function is equal to Y. The B and C functions are still equal to zero because we have no J or K component. So the A function appears here and here. Now AZ is zero because the A function, which is equal to Y, has no Z dependence. The AY function, however, is equal to what? The derivative of the Y function with respect to Y is 1. So that's going to equal negative AY, which is negative 1 times K, or just negative K. That's not equal to 0. So we've shown in two examples that the curl of a conservative function is 0. The curl of a non-conservative function, at least this non-conservative function, is not equal to 0. We can prove that in general the curl of a non-conservative function is not equal to 0. That the curl of a conservative function is equal to 0. Okay? So let F be a conservative function. Now what's a conservative function? One characterization of a conservative function is that it's a gradient of a potential function. We don't care what the potential function is. If F is a gradient of that potential function, then F equals Ux times I plus Uy times J plus Uz times K. That should be straightforward in terms of what we've discussed so far. So that del cross F equals what? Well, del cross F is going to be the determinant ijk, partial with respect to x, partial with respect to y, partial with respect to z, and then we're going to have ux, uy, and uz. Okay, so what do we get if we calculate this cross product? Well, we're going to have I times partial of uz with respect to y and the partial of uy with respect to z plus the j vector times the partial of ux with respect to z minus the partial of uz with respect to x plus the k vector multiplied by partial of uy with respect to x minus partial of ux with respect to y. Okay, so what's that equal? Well, partial derivatives, and we haven't proven this, but the partial derivative of a function with respect to z and y, okay, the partial derivative with respect to two different variables is independent of the order in which you take those derivatives. So if you do uz and then take the y derivative, it's the same as if you did uy and take the z derivative. So that these two terms are equal, except you have that minus sign, gives you 0. And you can verify that that is same over here. Derivatives with respect to x and z is the same as the derivative with respect to z and x. The derivative of u with respect to y, then with that with respect to x is the same as the derivative of u with respect to x, then that with respect to y. So this proves that if a field is conservative, since a conservative field is a gradient of a potential function, then the curl has to be 0. Now there's an alternative argument that's a little more complicated. But what we've shown is if f is conservative, then f equals the gradient of u for some function u. So the curl of f is the 0 vector. The converse also holds, but I'm going to give a hand-waving argument to that. So I can say also if del cross f is identically equal to 0, and I guess we could say identically equal to 0 here, equal to 0 for any value of x, y, z. Okay, then f is conservative. Okay, now I'm including this because y'all asked for a little bit more about the curl. There's a little bit more, and I'll give you just a little bit more in the next clip.